Okay friends, welcome to the second video on MRI. So in the last class we saw about what is the importance of this MRI and how it all started with the concept. Okay, now we'll actually get into the principles. Okay, fine. So we all know that our human body has 70 percentage water. We all know. Okay, the 70 percentage is water. So the chemical formula for water is H2O, and you'll be able to appreciate hydrogen is the element that is abundantly present inside our human body. Okay, the very interesting about this hydrogen is, if you see the molecular structure of hydrogen, it is having a single proton. Hydrogen is having a single proton. Okay, so that's the beauty of hydrogen. If you say the hydrogen, what will happen is, okay, I'll just put it as an hydrogen. So this is a single proton, this is my hydrogen molecule. It carries a positive charge. Okay, this is my hydrogen atom. So I'll just put it in a different color so that it will be able to identify. It carries a positive charge. Fine. Okay, the very important thing about this hydrogen nuclei is it is like your earth. So we can just put your hydrogen atom like your earth. What I mean by earth is it is going to spin on its own axis. It is spinning on its own axis. Okay, so in fact this is the spin that is going to be contributing. If a particular atom or a molecule is not going to have a spin, then this concept of MRI is not going to come at all. Okay, so spin is a very important one. So if you take a single proton, it is going to have a positive charge and it is going to be rotating on its own axis. Okay, now you'll be able to appreciate you have a charge which is continuously changing. Okay, so because of the rotation, it is said to be in a state of motion. Whenever there is a changing electrical field, we'll be able to appreciate there will be also an associated magnetic field. Okay, so whenever there is a changing electric field, there will be an associating magnetic field. So what I infer by this associated magnetic field is each proton because of its changing electrical field behaves like a simple bar magnet. Each proton, because of its nature of having a moving electrical field, will behave like a bar magnet. Okay, so each proton will behave like a bar magnet. That's a very, very important concept. Okay, so in this proton, it has an electrical charge as well as a magnetic field. So electrical charge as well as a magnetic field, both are there available in a proton. Fine, because of its spin and because it carries a positive charge, it generates an equivalent magnetic field. Hence your proton is equivalent to a simple bar magnet. Now you take our human body. If you take your human body, we said that there are huge amount of hydrogen atoms. What I mean by that is you're going to have lot of protons. Inside the human body. All these protons are spinning on its own axis. That's the beauty of it. Okay, we have good number of protons which are inside the body. All these protons are spinning on its own axis, and as I told earlier, each proton is going to act like a magnetic field. or each proton is going to act as a small bar magnet. Okay, each proton is going to act as a small bar magnet. Okay, now a very interesting thing we are going to do. This particular protons, they are randomly oriented. Okay, just think of a scenario of a classroom. Before the teacher entry into the classroom, you can see what happens inside the classroom. So all the students, they will be very random. They will be sitting in each direction, they will be chatting with others, they will be doing a variety of things. Okay, so that's a typical scenario where we can compare this proton state to a classroom. Okay, each proton can be compared to a student, will be in a random oriented direction. They'll be doing different kinds of task. Okay, now we are going to do a simple experiment. What we are going to do is, this is the person. We have the protons inside the body, we have the protons spinning in all directions. Fine. So we are going to do a very interesting experiment, like we're going to put the person in a magnetic field. We are going to put the person in a magnetic field. What happens if you put the person in a magnetic field? Something interesting is going to happen. Once you put the person inside a magnetic field, a very interesting phenomenon takes place. That is, all these protons which are randomly oriented, suddenly start to align. All the protons which were randomly oriented suddenly started to align in direction with the magnetic field. All the protons started to align in direction with the magnetic field, but with some exceptions. The exception is, most of the protons will lie parallel, few protons will lie anti-parallel. Most of the protons will lie parallel, few protons will lie in anti-parallel. Those protons which lie parallel to the magnetic field are said to be in a state of low energy, and those protons which are anti-parallel to the magnetic field are said to be in a state of high energy. Okay, again we can take the same classroom scenario, wherein you have initially the students are sitting randomly. Once a teacher enters the classroom, what will happen? All the students will try to be attentive. Okay, all the students will try to be attentive, so everyone will start listening to the class. Okay, now in all the classes we have some mischievous students. Okay, so those mischievous students, they will be look like they are aligning to the class, but what they will be doing, below they will be doing some other task. Okay, so they will be engaging in some other activities. Maybe they open their mobile phone and go for a chat. Okay, see, so all these students are parallel to the field, one or two students are anti-parallel, and for those who are parallel, they are having low energy. It is like they are always attentive, and these people who are somewhat excited, okay, they have some high energy, therefore they are not oriented. Okay, again they look like they are physically present, but mentally they are not present. Okay, that's what we can compare it to these protons. Most of the proton which are in the low energy state lie exactly parallel to the magnetic field, and few protons which lie in the same plane but anti-parallel to the applied magnetic field. Okay, that's a very interesting aspect that is taking place. Now one more interesting phenomenon that is going to be governed here is about the strength of the magnetic field. The strength of the magnetic field is going to play a very important part. Okay, so we'll take up that part in the next video. So what we have seen so far is, in our body we have abundant number of protons. All these protons are randomly oriented. Once we put them under a magnetic field, all these protons align. In that alignment, many of the protons are aligned perfectly parallel, few protons are aligned anti-parallel. those protons which are aligned parallel are said to be in a low energy state, and those protons which are anti-parallel are said to be in a high energy state. Okay, so we'll stop here. So in the next session we'll continue with other features about these things. Okay, thank you.